Okay guys, now we're going to look at intersections, and this is the final stage of discriminant, so follow up very closely. Intersections are what I mean by two functions intersecting with each other, just like shown in these three graphs, okay? So usually we apply these when a parabola intersects with a straight line graph, okay? So I'll show you the different cases, so watch carefully and make sure you remember all those three different cases, okay? So the first case is when the parabola intersects with a straight linear line and they happen to have two intersections, so one there and one there, okay? And that's the maximum amount of intersections they can have, right? So if we have two intersections, then the discriminant must be greater than 0. So guys, I treat this same as any other questions that we did in previously, because remember how I said talk about roots? The intersection, we also call them as roots, okay? And remember, if we have two different roots that are distinct from each other, see how they totally look different? This root is different from that root, isn't it? So therefore, these are two distinct roots, therefore the discriminant must be greater than 0. Remember how we kept talking about that? If there's two unequal roots, that means the discriminant must be greater than 0. So same applies for intersections, okay? So don't think it's brand new things. It's basically the same concept, all right? So that's when it has two intersections, discriminant must be greater than 0, okay? Now the next one, hope you can see that this time there's only one point of intersection, all right? So when the line is just a tangent to the parabola, okay? So it has one intersection, and in that case, there's only one distinct root, which means the two roots are equal, so therefore we only count it as one root. So remember previously when I keep talking about this, when it only has one root, the discriminant must be equal to 0, okay? If it's equal to 0, negative b plus root 0 divided by 2a is the same as negative b minus root 0 divided by 2a, right? Because 0 does not make any difference. So therefore we make that as just one solution, which we happen to have just one root, or one intersection in this case. Okay, so if it has one intersection, please remember that b squared minus 4ac, the discriminant, must be equal to 0. Okay, and finally, the last case is when they don't intersect at all, so when they're just far apart of each other. So the parabola has no intersections with the linear straight line, so therefore b squared minus 4ac, the discriminant, must be less than 0. Remember when I talked about the positive and negative definite quadratic functions? Remember how they were either positive or negative, and they were far apart from the x-axis, so they didn't have any roots? Remember then I told you that b squared minus 4ac must be less than 0 as well? That's because they don't have any roots. They don't meet at all with the x-axis. Okay, same applies for intersections. If there's no intersections, if they're far apart from each other, they don't touch each other at all. Same applies for this one. B squared minus 4ac must be less than 0 as well. Okay, like those positive and negative definites. Okay, so I hope that kind of makes a link between everything else, okay? So it's nothing completely new, they're all linked with each other, like what we did in the previous sections as well. Okay, so please remember these three sections, cases, or rather, b squared minus 4ac must be greater than 0 for two intersections, discriminant must be equal to 0 for one intersection, for no intersections, discriminant must be less than 0. Okay, and again here, if the discriminant is less than 0, it's a negative number. If we square it a negative number, it's undefined. Okay, if the square root of that number is undefined, the whole solution becomes undefined, so therefore no roots, or in this case, no intersections. Okay, hope that makes sense. So these three things are the only things you have to remember for intersections. Okay, so let's apply them onto our questions now. So starting with question 9. Find the value or values of k if the line kx plus y plus 4 equal to 0 is a tangent of y equals to x squared. Okay, so this is a linear line kx plus y plus 4, so we don't know what k is, and it's asking us to find what k is, so this is unknown. And it says it's a tangent of y equals to x squared. What's a tangent, guys? Tangent is just a line that just touches the parabola. okay, or whatever function it talks about, but this one is a parabola, isn't it? So the tangent just touches the parabola, so it only has one intersection, just like this graph over here. So this parabola is y equals to x squared, right? It's on the origin. And this, I don't know what this line looks like, but it should be a tangent, so it just touches it once. So I'm assuming that it will look like that. Okay? So now we're going to go ahead and find the values of k. So what should we do? So if they intersect once, guys, we can try attempt and find that. Maybe that will help. So what I'm going to do first is put y equals to x squared into the linear line y equals to negative kx minus 4. I just made y the subject from this one, okay? So I moved everything else onto the other side. So I made y the subject. So basically it's asking us to solve simultaneously, alright? See how this is y, this is y. So I'm just going to go x squared equals to negative kx plus minus 4, sorry. Okay? So now what I'm going to do is move everything onto one side so it looks like a quadratic. See how after I've merged these two together, it becomes some sort of quadratic? X squared plus kx plus 4 equal to 0. So just move everything onto one side and form it into some kind of quadratic. Now that we've got a quadratic, think about discriminant. Just the one that I've told you prior to this question. Guys, if it has one intersection, what did I talk about the discriminant? What did I say the discriminant will become? If it's just one solution, that means it's equal roots, therefore discriminant has to be equal to 0. And it says as they have only one intersection. Okay, just as I said. So the discriminant must be equal to 0 if it's only one intersection, and that usually applies for tangents. Okay, so now that we've got the property, okay, or the case, I'm going to apply my BAC into the formula. So you can see here, A is 1, the coefficient of x squared is 1, and B is k, the coefficient of x, and C is 4. Okay, the constant number 4. Can you see that? So let's just sub it into the b squared minus 4ac equal to 0, just like this. So b is k, so I'm going to go k squared minus 4 ac. A is 1, k is 4, so I'm going to go 1 times 4. Alright, and that's all equal to 0. Simplify, guys. K squared minus 4 squared, because see, 4 times 1 is just 4, times 4 makes 4 squared, doesn't it? Alright, I'm just going to leave it like that, because I'm going to go k plus 4, k minus 4 equal to 0. Because see how this one's k squared minus 4 squared? Square minus a square goes k plus 4, k minus 4. Just factorize it. Okay, so now k plus 4, k minus 4 equal to 0. Therefore, k is negative 4 or positive 4. Okay, negative 4 or positive 4. And that's the solutions for k. So k can have two values. Alright? So there's two values for k. One which is negative 4 and one which is positive 4. So I hope that made sense, guys. Basically all I did was make simultaneous equations. And you'll often see that if we solve simultaneously with a quadratic and a straight line, you'll end up with a quadratic, another quadratic looking like that. And then you apply your discriminant, okay? So make sure you know if it's one intersection, two intersections, or no intersections, okay? This one was no intersections, so I used b squared minus 4ac equal to 0. And then just solve it, alright? So I hope that made sense. That was question 9. Have a look. And let's move on. Question 10 says find the value or values of k so that y equals to x squared. So again, we have the same parabola this time. Y equals to x squared and y equals to 2x plus k. So we've got a different linear function this time. Have two intersections. Okay, they clearly say there's two intersections. So what I'm going to do is draw a little diagram. I always like to do diagrams because it really helps me a lot. Okay, but you don't have to do it every time. But if you do get trapped or a bit confused, try drawing a diagram like me. Okay, and then it will give you a better idea. Okay, but anyway, I drew my x squared, y equals to x squared like that. And I drew this y equals to 2x plus k. Okay, I don't know where it's going to be exactly, but I just drew a rough sketch of the linear line since I don't know what k is. So see how it's, but it says two intersections, so see how I've got one intersection there and another one there. So I have two intersections. So I've got a clear understanding of what the diagram looks like and how they're going to work with each other. So now I'm going to do the usual thing. I'm going to try to do the same process as I did for question 9. Okay, so I'm going to start by solving simultaneously. See how this is y equals to x squared, this is y equals to 2x plus k? This is y, this is also y, so I'm going to make them equal to each other. So x squared equals to 2x plus k. Alright, so I'm going to try to do some simultaneous equations. So now that I've done that, hope you guys know the next step. Because I want to make it into some sort of quadratic, I'm going to move it all onto one side to make it equal to 0. Okay, so it becomes x squared minus 2x minus k equal to 0. Alright. Now that we've got a decent looking quadratic, let's consider discriminant now. Okay, guys, do you remember what I said when we have two intersections? What happens with the discriminant? If there's two intersections, I hope you remember that b squared minus 4ac must be greater than 0, as there are two intersections, okay? And for those who are still confused, you've got to try to remember this, okay? Please try to remember this, because these are some crucial things you should remember. You shouldn't really sit in your exam thinking about why it's greater than 0 for too long, okay? So I want you to know, two intersections, discriminant must be greater than 0. Alright? So that's why I put that. Now, let's think about what a, b, and c are. A is coefficient of x squared, which is 1. B is coefficient of x, which is negative 2. And c is the constant number negative k. Okay, so I've got my a, b, and c. Let's substitute these into this value here. Okay, b squared minus 4ac is greater than 0. So sub it all in, like this. B is negative 2, so I put negative 2 squared minus 4, okay. A is 1, so I don't really want to put that there. And C is simply negative k, so I just put negative k there, and that's all greater than 0. Okay. Let's simplify this. Negative 2 squared is 4, okay, positive 4. Negative 4 times negative k is positive 4k, right? So be careful with looking at your signs, and that's all greater than 0. Now 4k is greater than negative 4. Okay, just moving 4 over to the other side. So I've got negative 4. Now solve for k, divide both sides by 4. K should be greater than negative 1. And that's the solution. That's the answer for k. So this time we have this inequality because since discriminant was greater than 0. Okay, so see how I actually applied the same process as question 9? I did the exactly same process as question 9, but the only difference here was the condition of the discriminant. Because there's two intersections, b squared minus 4ac, the discriminant must be greater than 0. Okay, so I hope you are familiar with this by now. That's question 10, that's the values for k, which makes two intersections. Okay, alright, that's question 10, let's move on. So question 11 says, find the value or values of k if the straight line y equals to kx and y equals to x squared plus 1 don't meet each other. Okay, this time, these two graphs, they don't meet each other at all. So if I like to draw a diagram, it's going to look like this. This is the parabola y equals to x squared plus 1. Okay, that's what it should look like. And y equals to kx, this is represented by this linear straight line that passes through the origin, since y equals to just kx. Now, I can't guarantee about the steepness. I don't know what k is, so I don't know how steep it's going to be, but that doesn't really matter as long as you draw a rough sketch. And the key thing is that they don't meet each other. They won't have any intersections. That's the key thing. So make sure you put that in your diagram, if you need to draw a diagram, that is. Okay, that's what it's going to look like. So what I'm going to do is start off like what we did in question 10 and 9, solving them simultaneously. Okay, so see how y equals to x squared plus 1 and y equals to kx. So I can let x squared plus 1 be equal to kx. Okay, because they're both equal to y. So x squared plus 1 equals to kx. I'm going to move kx onto the other side now to make it into a decent looking quadratic. So I have x squared minus kx plus 1 equal to 0. So that looks like a nice quadratic now. Now that I've got that, let's consider our discriminant. Okay, so discriminant, think about it guys. This time they don't have any intersections. What happens if they don't meet each other? Is the discriminant going to be greater than 0, equal to 0, less than 0? Have you guys picked one? Discriminant must be less than 0 here guys, because they don't meet each other. Alright? If they don't meet each other, the discriminant must be less than 0. Okay? So if it's less than 0, it's a negative number. If we square root a negative number, it's undefined, there's no solutions. So if that's undefined, the whole solution of the root is undefined. Okay, so there's no roots here, or in this case there's no intersections. Okay, they're apart from each other, and that's represented by this. Okay, alright, now that we've got that, let's consider A, B and C, so we can just sub it in. So here, A is simply the coefficient of x squared, which is 1. B is the coefficient of x, which is negative k. And C is the constant number here, which is just 1. Okay, do you see that? So we've got our A, B and C, and all we need to do now is sub it in to b squared minus 4ac is less than 0, like this. So b is negative k, so I put negative k squared minus 4. A is 1, C is also 1, so 1 times 1 is simply 1, isn't it? So I'm just going to put that 1 there, less than 0. Okay, simplify now. Negative k squared is just positive k squared. Negative 4 times 1 is simply negative 4, and that's less than 0. Now guys, all we need to do now is factorize. See how 4 is 2 squared? So k squared minus 2 squared, square minus square, we factorize it like this. K plus 2, k minus 2. That's less than 0. Okay? Now, if I want to solve for what k is, because it's an inequality, I like to draw a little graph, a parabola, and see how it's 2, negative 2. So therefore here, k would be negative 2. Here, k would be positive 2. Okay? So now it's less than 0. So therefore it must be below the axis, so it must be between here. Okay? So therefore, this final solution of k would be between negative 2 and 2. So k is greater than negative 2 and less than 2. That's our solution for question 11. Okay, that's the solutions or values for which k can be. Okay, for what that k can be, in order to make no intersections between these two lines. Alright? That's it. That's the answer to question 11. The key thing here was that b squared minus 4ac, the discriminant, was less than 0 since they don't meet each other. Okay, I know I'm keep stressing you guys out with all these discriminants, okay, but I just want to get these really stuck into your brain that, as I said, if there's no intersections, the discriminant is less than 0. If it just meets once, like a tangent, then the discriminant is equal to 0. If it passes the parabola and makes 2 intersections, that means discriminant has to be greater than 0, right? Yes? So hope, because I've been doing this repeatedly, saying this over and over again, hope that's already stuck in your head by now. Now that was discriminant. Hope you remember what discriminant is, b squared minus 4ac. So I hope you're really familiar with that now. And remember the types of roots, guys. The roots, depending on what the discriminant is, the roots can be either real or imaginary. Imaginary, you can also call it unreal. Okay? So make sure you can determine which one is real and unreal. And if it is real, you can consider them as either equal, unequal, rational or irrational. So make sure you can contrast between each of those, because they do in your exams ask you a lot of those. Alright, so make sure you're really good at telling the difference between each of those categories. Alright, and also have a clear understanding of those positive or negative definite quadratic functions, okay? If it's greater than 0, if it's greater than the x-axis, if it's floating, okay, positively or negatively, make sure you know the characteristics of those, because that's also commonly asked in your exams, and make sure you also know the intersections. Okay, so if you're still, for some of you who are still confused, I understand, because this discriminant is a little bit of a new concept, so I understand if you're still a bit struggling, but I really want you to understand what I've done today in today's lesson, okay? Because that's just about it. That's all you need to know about discriminant. Okay, so hope that helped. That was discriminant.